All right, section 3, we'll be looking at systems of linear equations. This one we learned in Algebra 2 in high school, maybe touch on it in Algebra 1 because it is a bit tougher, but nothing we won't be able to do. So without further ado, let's go ahead and get into it. We'll define what a system of linear equations is. All it is a system that consists of two or more linear equations in the same variables. So it's a lot easier to understand with an example. So let's go ahead and look at this one. We have 3x plus 2y equals 7, and x minus 3y equals a negative 5. All right, so this forms a system of linear equations. And it says in two variables because we have x's and we have y's. If you remember from the first lesson, these equations are linear equations, and they are in standard form right now. So in this case, the solutions of the system is, well, I shouldn't say always, but more often than not, it'll be a point of intersection. So say, for example, we were given that problem, right? This problem says solve the system of equations by graphing. Now, graphing is pretty much the easiest way to solve these. I shouldn't say easiest, but all that it requires is no algebra, pretty much just look at where the lines meet. And what do I mean by that? Well, if we were to look at the graph, right, we have y equals 2x minus 1, and y equals 2 over 3x minus 7. Now, I should note here, these two lines are those two lines that are graphed. All right. All we did was, like in the first lesson, convert standard form to slope-intercept form. And if you don't remember what those are, let me write those down. This is ax plus by equals c, and slope-intercept is the one we're used to, y equals mx plus b. And again, like we said in the first lesson, we can go from one to the other and vice versa. Right, so all we're doing is graphing those lines. After we graph those lines, all we have to see is where the lines meet. In this case, there's a big dot right here, or a big point, where they meet. And that point is a -1, -3. So -1, -3 is the solution for this system. So that's solving by graphing. Now, there's two other popular ways we tend to do this. They're more algebraic. We don't really use graphs. We don't need them. So first one is a substitution method. Now, those are the steps, right? So well, I won't go over them. I'll let you read them. I say we go over them by doing an example so we don't get overwhelmed. Say they're asking you to solve a system of equations using substitution. Now, how do we do that? Well, we have the steps to our right. First things first, step 1, we'll rearrange one equation so that it is in terms of the other. Or let me say that again. Rearrange one equation so that one of the variables is in terms of the other. What does that mean? Well, for example, let's take this second equation. This equation we see right here. Let's go ahead and take that equation. And all we're going to do is move this -2x to the other side of the equation so that it becomes a positive 2x. And now we have y equals 2x minus 1. This is what we mean by that. We solve for one variable. We don't want both variables, x and y, to be on the same side. So we have y equals 2x minus 1. Why do we want to do that? The reason we want to do that is because now for step 2, we can substitute 2x minus 1 instead of y. So wherever we see y, we can plug in 2x minus 1 and then solve for x. If you need, you can pause at any moment, but let me show you what that's going to look like. We're going to go ahead and get that first equation now. 2x minus 3y equals 7. And now, just as we said, instead of y, instead of y here, we're going to plug in 2x minus 1. Why? Because they're equal, right? Y is equal to 2x minus 1. So instead of y, we're going to plug in 2x minus 1, just as we do here. And let's go ahead and clean this up a bit. If we distribute that 3, we'll get 2x minus 6x plus 3 equals 7. The 2x minus 6x will now become negative 4x. And then we'll subtract 3 from both sides so that the positive 3 and negative 3 cancel out. We have negative 4x equals 4. So this is purely algebra to solve for x. We're going to divide both sides by negative 4 so that those cancel out. And we finally get that x is equal to negative 1. So how were we able to do that? By substituting 2x minus 1 for y, right? We want to get rid of that y, so we only have x in our equation, which makes it a lot easier to solve for x, which in this case gave us negative 1. So we have x. We know x is negative 1, but we still need y. How can we solve for y? I'm going to erase this just so it doesn't look like too much of a mess. But notice this equation right here. They're telling us y is equal to 2x minus 1. And if we know x, what can we do? Well, just substitute negative 1 for x in that equation. So in this case, what would that look like? Well, if we put negative 1 instead of x, we're going to multiply 2 times negative 1 minus 1. So that is negative 2 minus 1. And negative 2 minus 1 is just negative 3. So y is negative 3. And there it is. We have our x and our y. Therefore, that is the solution to the system of equations. If you need to rewind and kind of go over the steps a little slower, you can go ahead and do that. Or maybe if you want to practice some of your own, you have problems in your packet, you can try to practice. And if you have any questions, you could always ask. That's what we are here for. This is known as a substitution method. This is the one I used personally going through middle school, high school, college. The substitution method is the method I liked. But there is the other known as the elimination method. So the elimination method, well, there's the steps. Again, I'm not going to go over them because I find it easier to do it with an example. So let's say, for example, we have this system of equations. We have negative 3y plus 4x equals 11. And we have 5y minus 2x equals 5. So how do we do this using the elimination method? Well, like it says, step 1 is multiply an equation so that variables can cancel. In this case, we're going to multiply the second equation, right? This equation right here. We're going to multiply it by 2. Now let me show you why we're going to do that. If we multiply that equation by 2, well, the 2 has to distribute to every single term. So that becomes 10y minus 4x equals 10. So what happens? Why do we do this? Well, now we have our equations are negative 3y plus 4x equals 11, so that one remains unchanged. But now we have our new one, 10y minus 4x equals 10. And the reason we did that is because now we can add these two equations. And what do you notice? Well, I see a positive 4x, right? We see a positive 4x, and we see a negative 4x. So what happens there? Well, what we can do is those two can cancel out. What does that leave us? Well, negative 3y plus 10y will give us 7y, and then 11 plus 10 is 21. So 7y is equal to 21, which means y is equal to 3. Now, this method seems a lot easier, and you can decide for yourself. A lot of people do find it a lot easier to use this method. But again, it's whatever fits your style. We're not done yet, though. We have y. Y equals 3. So we have y equals 3, but we're still missing a variable. We're still missing x. So like the last method, we're going to choose an equation to plug in y and get x. In this case, we'll use this equation, negative 3y plus 4x equals 11. But you can use any of the equations where we have here. You can use the other equation, 5y minus 2x equals 5. They will both work. So now we know y is equal to 3, so that's what we're going to plug in. So negative 3 times 3, that'll give us, so that's what we plugged in. That'll give us negative 9 plus 4x equals 11. And then just add 11 to both sides to isolate the x, which gives us 4x equals 20. And our last step is to divide both sides by 4 so that we have x equal to 5. And there we go. We have our solution. X is 5, y is 3. So this is the elimination method to solve systems of linear equations. Last thing we need to go over are something where we might have, I'd say, odd solutions or not solutions that are too common, but we need to address nonetheless. So, solutions of system of equations. There's different solutions. We've mostly been going over this one here, the one where we have one solution. And that solution is a point, right? The point where the lines meet. But what about parallel lines? Well, those lines, parallel lines, never cross. So where's the solution? As you can read there, they have no solution because parallel lines will never cross. And then we have one where we have the same line. The same line, if it's just a line on top of the other line, well, they're crossing at every single point on that line. So that's why there are infinite solutions, because every single point on that line will be a solution. And let me give you an example. The one for the intersection at one point, we've been going over. That's the one we used for the substitution method and the elimination method. This is just another example where those two lines will meet at one point. The parallel lines we have here, and as we've learned, parallel lines have the same slope. So that's how we know these two lines are parallel. These will have no solution. And finally, y equals 3x minus 2 and 2y equals 6x minus 4. If you simplify, they will turn out to be the same line. meaning they will have an infinite number of solutions. So that's an example of the 3 types. And that's it for this lesson. If you have any questions, like I said, go ahead and ask. You can practice some problems for yourself. That's how we get better. And see what method you end up liking more.